in 1.5, we're going to talk about first a family of functions, right? Which is the following. A family of functions is a group of functions whose graphs look the same way. They have the same characteristics. So for example, all quadratic equations, no matter how they look, they will always give you a parabola. So that is a family of functions, right? All cubic functions will look the same way. All absolute value functions will look the same way when you graph them. Those are families of functions. The parent function is the simplest of all the functions in a family, right? So for example, this is a quadratic function. It's a fairly, complex quadratic function with a whole bunch of embellishments. The parent function of this is the most basic form of the quadratic function, this, y equals x squared. So in this section, we're going to walk through several of these families of functions, of these parent functions. The most simple we're going to talk about is what we call a constant function. A constant function, we saw this when we were doing like increasing, decreasing, and constant, right? A constant function is basically a function that it's a horizontal line. It's like f of x is equal to some number 3, right? Or y is equal to some number 3, and it's just a horizontal line that passes through y equals that, okay? That value, 3 or whatever. Next, you have the identity function. This is, what you know as y equals x, or we can rewrite it as f of x equals x. That's the parent function, but if you add to it, y equals like 3x plus 5, negative 2x minus 7, right? Those are the other members in that family. Okay, we talked about a quadratic function, y equals x squared. All of their graphs will look like a parabola. Okay, a cubic function is y equals x cubed, okay? Now, let's talk a little bit about how the graphs of these things behave, okay? So let's talk about y equals x squared, the parabola. When you just have y equals x squared, the vertex is right here at 0, 0, okay? Now, the way in which you create a parabola, and this is how you're going to graph this, is this. From the vertex, this is a y equals x squared, right? From the vertex, if you go over 1 unit to the right, you go up 1 squared, which is how much? 1. Now, if you go over 2 from the vertex, if you go over 2, you go up 2 squared, which is 4. If you go over 3, you go up 3 squared, which is 9. So that's how we graph the x squares. Y equals x cubed has a similar situation. And we're going to do this again and again and again today. Y equals x cubed has a similar situation. The center is here. If I go over 1, I go up 1 cubed, which is 1. From this, if I go over to the right 2, I go up 2 cubed, which is 8. Okay? So that's how the graphs are different. Now, I'm just introducing, and then when we graph later, we're going to do them over and over again, so it'll sink in. Okay, next I have a square root function. This is how it looks. So for the square root function, you only have half of an arm, right? So remember that. There is an endpoint and then it goes up. The reciprocal function is the only one, okay, that you're going to graph on the calculator. Okay? Yeah, that's the only one that you'll be able to do it with a calculator, okay? And then we have an absolute value function, which you have been able, like you've graphed before. So let's talk about transformations, and then we're going to graph a couple of examples. Transformations are when there are any changes in the graph, right, that affect the shape of the graph. Okay? Question?
Oh yeah, so on the cubic function, so it goes up and it goes down, right?
Mm-hmm.
So do you not do anything in the down part?
You do. We're going to do it later. It's symmetric. So however much you go, left up, you also go like right up, left down. Yeah. Okay. So we're going to first start with a translation. A translation is when the graph is shifted either vertically or horizontally, right? So it shifts the graph up and down. So now, how does a vertical translation look? Look at this blue graph here. Suppose this is y equals x squared, right? Now, to move this graph up, I can write another function, y equals x squared plus 3. That plus 3 moves the graph up 3 units, okay? To move it down 3 units, I would say y equals x squared minus 3. That minus 3 moves it down 3 units. All right? So that's how you can move a graph up or down. So the plus 3 and the minus 3, these are called vertical translations, right? A vertical translation. And, it basically moves up and down that many units. Okay. A horizontal transformation. Suppose this is y equals x squared. Okay? The blue one. The green one, look, it's y equals x minus 2 squared. So now you have a plus or minus inside of the, inside parentheses along with the x. So this one, the change is happening to the x, so it moves right or left. This one was outside the x, so the change was happening to the y. So how do you know if it moves left or right? Here's how we know. Take this stuff inside the parenthesis. Only when it's inside the parenthesis do you do this. Take the stuff inside the parenthesis, set it equal to 0. X equals what?
2.
Positive 2 means it moves to the positive side 2 units. Okay? Yeah. Yeah. Here, what do you think the equation for that red one will look if it moved to the left?
It's going to be plus 2, so it's negative.
So y is equal to x plus 2 squared. That's why it moves to the left. Okay. So now, here's what we're going to do. Okay. Okay. We're going to graph x squared minus 3. First of all, this is an x squared. It's a parabola. Yes?
Yeah.
Okay. What does the negative 3 do?
It shifts it to right.
Shifts it down 3. Okay.
I'm sorry, I thought it was inside.
So now, okay. So instead of the vertex being at 0, 0, it's going to be down here at 0, comma, negative 3. And let's put that in there, right? 0, comma, negative 3. Okay? You are going to label those. Now, this is a quadratic function, a parabola. That means, here's what we're going to do. If you move over to the right 1 unit, how much are you going to go up? 1 squared, 1, so right here. So that point is at 1, comma, negative 2. Okay, we'll do the other side later. Now, you're going to do it for a total of 5 points. So here, let me do the whole thing, and then you'll see. It's going to be easier than you think. So now, from the vertex, you always have to go from the vertex, not from the point that you just put up. from the vertex, if I go over 2, how much am I going to go up? 4. 1, 2, 3, 4, right here. That point is 2, 1.
Do we have to write like the coordinate point?
Yes. Now, okay, you're going to mirror these points on the other side. So the first one in the purple, you're going to mirror it on this side, right? And that's going to be -1, -2. Okay? The blue one, on this side, it's going to be -2, +1. And those are your 5 points. Now, okay, now you're going to graph your parabola. I want you to be careful because this is a parabola. It does not have a corner at the vertex. So I like to make the curve first, and then you have to show it going up. Also remember, this is not connect the dots. So if you stop at the blue points, that's not a parabola. That's just, I don't know what it is. It's just a curve, right? It's just a... So extend it past this. Don't just end it here. Yes?
What's the reason that you made the ones above, like the y-axis blue?
Just so you guys could see it better. That's okay. Yeah. Just so you guys could, just so you know which point I'm graphing. Because also later when I was going to mirror it, I was gonna when I was gonna mirror it later. So okay, so the next one has 2 transformations. The -4 moves it to the right 4 units, and this moves it up 2 units. So instead of 0, 0, we're going to be at 4, 2 here. Okay? Now, same thing, it's a parabola. So from the vertex, which is now at 4, 2, if I go over 1, I go up 1. I'll do those in red so we can mirror them easier later, right? So you go over 1, up 1. And that's going to be the point 5, 3. Okay? Then from the vertex, if I go over 2, I need to go up 4. 1, 2, 3, 4. And that's going to be 6, 6. All right? Okay, same thing. Mirror them on the other side. So the red one comes over here. The blue one over here. Put the points. So that's 3, 3. And this one is 2, 6. Okay. When you have to connect and graph, again, just go past those points right here and, make it look like an even parabola. All right? Okay. All right, so let's talk about dilations. So, vertical and horizontal dilations. A vertical dilation is when you have a number in front of the function. So for example, suppose this blue one, the original, is y = x squared. The green one will be y = 3x squared. And that number 3, because it's in front of the function, that's a vertical dilation. Now, here, do you see how the red one became wider? It becomes wider when the number in front is a fraction between 0 and 1. So 1/2 x squared, it becomes wider. All right? Now, these things, they have different names. So like if it becomes narrower, it's a compression. I'm sorry, if it becomes narrower, it's an expansion. If it becomes wider, it's a compression. I don't need us to bother with that. What you need to know is if that number is in front of the function, that this is a vertical dilation. Okay? Now, a horizontal dilation is if the number is like next to the x. So for example, if instead of having y equals x squared, suppose I have y equals 3x squared. Do you see how the 3 now is inside the parentheses and it's also being squared? That's a horizontal dilation. And again, all I need you to know is if you see it, to recognize that it's a horizontal dilation. Or it could look, for example, like this: y equals 1 over 4x squared. Okay? I don't need you to know compression or expansion, just that it's a horizontal or a vertical dilation. All right? Okay, so how do we graph it when you have it in a function? So here's how you graph it. This one here, the 2x squared, there is no vertical or horizontal shift, right? So the vertex is at 0, 0. Okay? Now, what is the 2 going to do to this? What is it? What type of transformation is it? It's a vertical dilation. So, here's what we're going to do. In a normal parabola, if I went over 1, I would have gone up, how much? 1. But now you have to multiply that by 2. So instead of going up 1, how much am I going to go up? 2. Right. You squared and then you multiply. So this is now going to be 1 comma 2. Next, when you go over 2, you would have gone up 4. Now you go up 8. Okay, so let's do that again. Before, when you went over 1, you would have gone up 1. But you see how there is a 2 in front of it? Multiply that number by 2. So you get 2. Okay. Also, before, when I went over 2, I should have gone up 4. But now I go 4 times 2, 8 up. Okay? And then when you mirror these this way, you get negative 1 comma 2, negative 2 comma 8, and this was 0, 0. All right, so it's much narrower than before.
Do we have to mark 0, 0?
So you need 5 points. That'll get you the 5th point.
No. I mean, like write 0, 0.
Yeah, you need to write down coordinates for 5 points. Yes.
So when like the vertical dilation, like let's say 4x squared, and you can't really fit 7 points on the graph, or like 6, because it goes to 5.
So normally, you should have enough for like the 5. Right? Like, so if you went 1 more, yes, it would have gone up too much. But if you only go up like 1 and then 2 levels, you should normally have enough. Because like, you know, we won't give you like too big of a number. Yeah. Okay. Other questions? Yeah.
I still don't understand what 8, like going up 8.
Okay. So did you understand before when we went over 2, we would have gone up 4? Okay. So when we went over 2, we would have gone up 4, right? But you see how there is a 2 in front of this? You just have to multiply that number by 2. The number of...
That's on 2, which is what I don't understand. Like,
Huh?
which 4? Where's the 4 from? Multiply by 2? She doesn't understand. I also don't understand. The 2 in front of it? Where's the, okay, so where's the 4 from?
Okay. So when you're graphing a parabola, okay? So look, Leah, look here. When you're graphing a parabola, you start here. Because the parabola is something squared, from the vertex, if you go over 1 unit, like just move over 1 block, you go up 1 squared block. So that's 1. Okay? I'll show you another way right now. If you go over 2, you go up 2 squared. Okay, because this one has an additional 2 in front of it here, we're multiplying each of these. Why is it? We're multiplying each of these by an additional 2. Now, for some people, this is like very easy and quick to do. For others, it's not. If you're not feeling this, another way you can do is just pick points. So what you have to do first is this. Figure out what the vertex is, right? And here the vertex is at x equals 0, right? Now you're going to pick points. Pick a point. Can you open the door, please? Pick a point. Okay, go 1 unit to the right of the vertex, x equals 1. Go 1, and then 1 other unit, x equals 2. And now plug them into your function, 2x squared. So 2 times 1 squared, 2 times 2 squared. Okay, that also works. Right, so remember in the beginning I said I'll show you a couple ways. This is the other way. All right, so for this one, let's do it in the 2 ways as well. So here, the vertex is going to be 0, 0. Okay, now, when you go over 1, you should have gone up 1, right? But this one, what does it have in front? A 4th. So now how much are you going to go up? Just a 4th. And when you go over 2, you should have gone up 4, but now you go up 1. Mirror. Because there is a 4th in front. And yes, you do have to put the points. I'm not for this one, but you have to put them up. I'll put them in a little bit. Let's do the table. Just yeah, or you could do 1/4, comma 1.
Oh, okay.
Yeah. Yeah.
Wait, well, why do we have to put like the points? What's the reason so that you can
How else would you graph the?
why else do why do you have to write them out? Like,
So I know that you've graphed at the correct points. Right? Because somebody else could just go, okay, that's my parabola, but like we need to make sure that you've graphed correctly. Okay? Okay. So so here we go. The vertex was at 0, 0, right? X is 0. The points that you pick here are going to be 1 to the right and then another 1 to the right. Right? And then plug them in here. So you get 1/4 times 1 squared is 1/4. And then 1/4 times 2 squared is 1. Right? So this one is 2, comma 1. And this one is 1, comma 1/4.
Do we have to do the math for that?
Which one? Okay.
You don't have to do the math for that?
You can either graph it just by, this, or if this isn't something that, like, if you're not getting that, you can do it this way. Okay. So, okay, let's move on. Okay. So, I'm going to pick up the pace a little bit. So, here we go. What if you have a negative in front? That's a reflection around the x-axis. So instead of going up, you go down. So if you have a negative in front, it's a reflection around the x-axis. Okay? Yeah.
did we not give an example of the horizontal? Are we not doing?
No. Okay. So take a look at this one. If I have a negative in front of the function, that's a reflection around the x-axis. And you're going to be asked later on what transformations are. So you have to say it in like the correct language, right? Okay, so here we go. The vertex here is 0, 0. So here, when you go over 1, we would have gone up 1. But now that there is a negative, you go down 1. When you go over 2, we would have gone up 4, but now I go down 4. Okay, and again, you have to put in the coordinates and you have to, label all of that good stuff. If you want to do a table, you can do a table. Put in 1, put in 2, and then you have to mirror the numbers over to the other side. Okay. Yep.
How does this reflect in the x-axis?
Because it would have looked like this, but now it's a reflection around the x-axis. It's flipped over horizontally around the x-axis.
Oh.
Yeah. Okay?
Not like...
It's not symmetric around.
Oh, okay.
Not symmetric. It's a reflection. You flip it down. So here, take a look. This one is a reflection around the x-axis. The plus 1 moves the function over 1, and this moves it up 2. So now the vertex is going to be to the left 1, up 2. It's going to be at -1, 2. Now, there is a reflection around the x-axis, meaning from that red vertex, if I go to the right 1, I have to go down 1. And if I go right 2, I need to go down 4. Okay. So from this, if I go to the right 1, because there's a negative in front, I don't go up anymore. Now I go down 1. And if I go over 2 units, then I go down 4 units. Okay? Now, before I take questions, you can also do a table. In your table, this time the x value of your vertex was -1. The points that you're going to put here is after -1, you have 0, then 1. Okay? Those are the points that you pick. You're going to put them in here and just generate the 2 points. Okay, yes?
But because of those parentheses, isn't that also like a horizontal dilation?
No, it's only if there is a number in front of the x. So if it was like
a coefficient?
Yeah, like a 3x plus 1.
Oh, okay.
Okay? So here, we're going to mirror these points here and here. So your parabola will look like this. Okay. Yes?
For reflection in the x-axis,
Mm-hmm.
so in the example, it's like on its side. Oh.
So that's only a square root. That's why.
Okay.
So whatever the graph is, it literally just flips down.
Oh wait, so why is this one on its side?
This is not because this is not a parabola. This is a square root graph.
Oh.
This is y equals square root of x. And then here, this is y equals negative square root of x. Okay. So, okay. So, next, we're going to do a couple of cubic graphs. Okay? All right. So, wait a minute. We're not going to use a calculator on this one just yet. You know what? I think I will. So for these, I will use, I'm okay if we use a calculator for the time being. So let's go ahead and take out your calculators. That's why we're doing it over 2 days. Okay. Before we plug this in, okay? Before we plug this in, let's do the questions underneath here. So the parent function, you would have to write down f of x is equal to x cubed. Okay? Transformations. There could be one, there could be two, there could be more than that. But you have to list every single one. So the negative is a reflection around the x-axis. Okay? The 2 is a vertical dilation. The plus 3 moves it to the left 3 units, so it's a horizontal shift.
So we don't need to specify.
You do 3 units to the left.
For vertical dive, we don't have to specify that.
Huh?
For the vertical dive.
That's all you have to say is vertical dilation. Can somebody open the door, please? Okay. So here's what I want you to do here. So when we graph, right? It's horizontal shift left 3 units. So we're going to graph negative 2, x plus 3 to the power of 3. Go ahead and graph this, please. Okay. 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 So the first point you're going to put on there is that the center of this would have been at 0, 0. But now it's shifted left 3. So it's here, negative 3, comma 0. Okay? Next, what I want you to do is this. In order for you to be able to get like the whole number values, go to Window, Trace, Graph Trace, and just stop there. In trace mode, you can put in any value that you want. So for example, you see how the center was at x equals negative 3?
Yeah.
Put a point 1 unit to the right. So negative 2. Negative 2, enter. It's negative 2, negative 2.
How did you do that?
Okay. Just type it in without moving it.
Just type in negative 2 and enter. Where?
Okay, so let's start again.
On here.
Menu.
Just press
You have to be in trace mode. Menu, trace, graph trace. Now just type in, let's type in 1 more to the right. So negative 1, minus 1, enter, negative 1, comma, negative 16. Now, that's too low and not like that's too big a number to graph. So it's fine if you have, just the negative 2, comma, negative 2. But let's also put 1 from the left. So to the left of negative 3, I have negative 4. Without pressing anything else, I just type in negative 4, enter, and it's at 2. Okay?
Wow.
Now let's do another one. Negative 5, enter, 16. Again, that's too big. You don't have to go that far. But make sure you give it that, yeah. Okay. 3 because it went too far off the grid. Okay, so look at this one. Let's graph this one. Press tab.
Could you go back to the last one?
Press tab, go up, control, delete, enter, and it'll reset things for you.
I just spammed the delete button. Yeah, I also
Me
did that.
too.
If you do control delete, it just deletes it, and if you press enter, it takes away all the dots. So, we're going to put in negative square root x plus 1 exit out plus 2.